Gravimetric analysis is a set of laboratory methods used to determine the mass or concentration of a substance by measuring changes in mass. The term analyte might refer to the substance that we are attempting to measure. Gravimetric analysis could be used to address the following question. What is the concentration of the analyte in a solution? How pure is the sample? This sample could be either solid or in solution. The objective of this method is to determine the chloride ion concentration of a solution by gravimetric analysis.
Coming up next, I will talk about sampling techniques or how to collect seawater. First, the number of casts and depth in each cast are assigned. Then, depth to be sampled and the total volume to be collected for the current cast are determined. We need to ensure that the jet flow and gas water sampling devices are in the open position and that all valves and spigots are closed. Then, attach the CTD to the base of the line and then lower it into the water. For the deepest depth in the profile, rig a sampling device onto the line immediately following the CTD. Make sure the line is properly fit into the device bracket and the screws are tightened. Then, attach a weight messenger to each device except for the deepest sampling depth before lowering it into the water. Lower the line and the distance between the first specified depth and the next. Then, rig another sampling device. Note that for depth interval where large volume water samples are collected, a total of 2 times 12 liter bottles are loaded consecutively at approximately 0.75 meters apart. For the last one, after all the devices are on the line, lower the line to the deepest.
Hi, now we will walk through the complete process of sampling preparation. Let's start with the preparation phase. In a conical flask, mix about 20 ml of diluted seawater with 115 ml of distilled water. Add 1 drop of methyl orange indicator. Slowly add dilute nitric acid until the indicator turns pink. Then add 1 ml of 6 molar nitric acid. Next, we move on to the precipitation and digestion. Slowly add 55 ml of 0.1 mol per liter silver nitrate solution drop by drop from a burette. Allow the solution to sit for 1 minute, then boil the solution and let it cool. Leave it to stand in the dark for at least an hour until the precipitate forms. Third is filtration. Transfer the precipitate to the Bunsen's funnel. Ensure you wash away any remaining particles from the conical flask using a small quantity of distilled water. Fourth is washing. We will wash the precipitate. This step involves washing it 3 times with a few ml of diluted nitric acid solution. After the acid wash, rinse the precipitate 3 more times with a few ml of distilled water. Next is drying. Carefully place the filter paper containing the precipitate onto a petri dish. Let it dry overnight to ensure all moisture is removed. Lastly, the process is analysis. Once dried, measure the weight of the filter paper with the precipitate. To determine the weight of the dried precipitate, subtract the previously known weight of the filter paper from the total weight. And there you have it. You have successfully completed the sampling preparation process, including preparation, precipitation and digestion, filtration, washing, drying, and also analysis.
Let's calculate the chloride concentration based on the mass of the silver chloride precipitate formed during the gravimetric analysis. Using the given data, we can calculate the mole of the silver chloride by the mass of the silver chloride will be divided by the molar mass of the silver chloride. Since 1 mole of silver chloride corresponds to the 1 mole of iron chloride, the mole will be same as silver chloride. Since we start with known volume of seawater, which is 20 ml, we need to convert the mole to the concentration using the formula mole of the iron chloride divided by the volume of the seawater in liter, and we will get the chloride concentration, which is 0.0436 mole per liter.
As the result for the experiment, firstly, the left flask showed a cloudy white precipitate of silver chloride that forms upon the additions of silver nitrate to the chloride sample solutions. Next, the right flask, it shows heating and standing process. The silver chloride precipitate is seen to coagulate into large clumps. Then, it will leaving a clear solution.
In conclusion, gravimetry analysis is a dependable and precise technique used to measure chloride levels in seawater, offering valuable information on salinity and the ecological health of marine systems. This method supports environmental monitoring, research efforts, and the optimal functioning of desalination facilities. By employing gravimetry analysis, scientists, researchers, and also environmentalists can make informed choices and implement necessary measures to safeguard and conserve marine ecosystem. This precise and reliable technique is crucial in our ongoing efforts to protect the health of our oceans and ensure the sustainability of marine life for future generations. Together, we can make a difference in preserving our planet's most vital resource.